Time Travel, Unraveling the Mysteries of Temporal Journeys. Introduction. Welcome, intrepid explorers of the cosmos, to another mind-bending episode of Sci Discovery Chronicles. I'm your host, and today we are embarking on a journey that transcends the very fabric of our reality. We're diving headfirst into the captivating world of time travel. From H.G. Wells to Doctor Who, the concept of time travel has captured our imaginations for generations. But is it merely the stuff of science fiction, or could there be a kernel of scientific truth to this tantalizing idea? Buckle up, because we're about to navigate the twisting corridors of spacetime to find out the nature of time. Before we can understand time travel, we need to grasp the nature of time itself. And let me tell you, it's far stranger than you might think. Einstein's revelations. At the turn of the 20th century, a patent clerk named Albert Einstein turned physics on its head with his theory of special relativity. He proposed something radical: time isn't absolute. It can stretch and contract depending on your motion or the gravity around you. Imagine you're on a spaceship traveling at nearly the speed of light. For you, only a year might pass, but when you return to Earth, you'd find that decades have elapsed. Congratulations, you've just traveled to the future. This isn't just theory. We've measured this effect using atomic clocks on airplanes and satellites. The GPS in your phone even has to account for it to work properly. Time dilation, as it's called, is our first piece of evidence that time travel, at least to the future, is possible. The block universe. But Einstein wasn't done messing with our heads. His theory of general relativity suggests something even more mind-bending. Past, present, and future might all exist simultaneously in what physicists call a block universe. Picture time as a loaf of bread. Each slice represents a moment in time. From our perspective, we're moving through these slices one by one. But what if all the slices, past, present, and future, exist at once? This idea challenges our notion of a now that's somehow more real than the past or future. If the block universe is real, it opens up intriguing possibilities for time travel. After all, if every moment in time already exists, couldn't we find a way to access different points in that four-dimensional spacetime continuum? Potential methods of time travel. Now that we've laid the groundwork, let's explore some of the ways scientists think time travel might be possible. Wormholes. First up, wormholes. These theoretical tunnels through spacetime could potentially connect to distant points in space or time. Imagine folding a piece of paper and poking a hole through both layers. The distance between the holes on the paper is much shorter than if you had to travel across the surface. Wormholes are predicted by Einstein's equations, but there's a catch. They'd likely collapse instantly unless propped open by some form of negative energy or exotic matter. We don't know if such matter exists, but if it does, wormholes could be our ticket to time travel. Cosmic strings. Next, we have cosmic strings. These are hypothetical defects in the fabric of spacetime, left over from the early universe. They're incredibly thin but enormously dense, and they might be capable of warping spacetime enough to create closed time-like curves, paths through spacetime that loop back on themselves. If you could fly a spaceship around two of these strings with just the right trajectory, you might find yourself arriving back where you started before you left. It's a wild idea, but one that's mathematically possible according to our current understanding of physics. Tipler cylinders. Frank Tipler, a physicist with a flair for the extreme, proposed another method: a massive rotating cylinder. If a cylinder with sufficient mass and density rotated fast enough, it could theoretically twist spacetime around itself. An object following a specific path around this cylinder might find itself arriving back at its starting point before it left. It's an engineering challenge of galactic proportions, but it's another example of how extreme conditions could potentially allow for time travel. Paradoxes and problems. Now, I know what you're thinking. If time travel is possible, where are all the time travelers? And what about all those paradoxes we've seen in movies? The grandfather paradox. The most famous of these is the grandfather paradox. Imagine you travel back in time and prevent your grandparents from meeting. This would mean you were never born, so how could you have traveled back in time in the first place? Some physicists propose that this paradox could be resolved by the existence of multiple timelines or parallel universes. In this view, your actions in the past would create a new timeline, leaving your original timeline intact. The Bootstrap Paradox. Then there's the Bootstrap Paradox. Imagine you're a music lover who travels back in time and gives Beethoven the sheet music for his symphonies before he's composed them. Beethoven then writes these symphonies based on the sheet music you gave him. But where did the music originally come from? These paradoxes highlight the logical knots we tie ourselves in when we consider time travel. They don't necessarily mean time travel is impossible, but they do suggest that if it is possible, it might work in ways we haven't yet imagined. The arrow of time. There's another wrinkle in our time travel dreams, the arrow of time. We experience time as flowing in one direction, from past to future. This is closely tied to the concept of entropy, the tendency for systems to become more disordered over time. Breaking an egg is easy, unbreaking it is practically impossible. This irreversibility seems to be a fundamental feature of our universe. Some scientists argue that this directional nature of time might make backwards time travel impossible, even if forwards time travel is allowed. Current research and experiments. While we can't build a time machine just yet, scientists are conducting fascinating experiments that probe the nature of time. Quantum time travel. In the realm of quantum mechanics, researchers have performed experiments that mimic certain aspects of time travel. In one study, scientists used quantum computers to simulate what happens when you send a quantum particle back in time to interact with its older self. These experiments don't actually send anything back in time, but they do help us understand how time travel-like situations might play out at the quantum level. Time crystals. Another intriguing development is the creation of time crystals. These are structures that repeat in time the way normal crystals repeat in space. They challenge our understanding of how systems behave over time and could provide new insights into the nature of time itself. Implications and possibilities. Let's take a moment to consider, what if we could time travel? The implications would be staggering. Scientific breakthroughs. Imagine being able to observe the Big Bang firsthand, or to see how life first emerged on Earth. We could solve countless historical mysteries and advance our understanding of the universe by leaps and bounds. Ethical concerns. But with great power comes great responsibility. The ability to change the past could have unforeseen consequences. Who gets to decide what changes are made? How do we prevent misuse? Philosophical questions. Time travel also raises profound philosophical questions. If we can change the past, do we truly have free will? Or are our actions predetermined, part of a grand tapestry of spacetime that's already woven? Conclusion. As we reach the end of our temporal journey, we find ourselves with more questions than answers. Is time travel possible? The honest answer is, we don't know yet. What we do know is that our understanding of time has come a long way since Newton thought of it as an absolute, unchanging river. We now see it as a flexible, dynamic part of the fabric of our universe, interwoven with space in ways we're still trying to unravel. While we may not be stepping into time machines anytime soon, the pursuit of time travel pushes us to explore the deepest mysteries of physics. It challenges us to think beyond our everyday experiences and imagine realities far stranger than fiction. As we continue to probe the nature of time, who knows what we'll discover? The next breakthrough could be just around the corner, or perhaps just a moment away in the future. Until next time, keep questioning, keep exploring, and keep your eyes on the horizons of science. This is Sci Discovery Chronicles, signing off.